This lesson is on Pascal's triangle, and Pascal's triangle has lots of different properties and lots of different patterns. What we are going to use it for today is to expand polynomials. For example, if I gave you the problem x plus 3y to the fifth, think about what that would mean. That would mean, and you don't have to write this down, that would mean that you have to write this 5 times, okay, and then double distribute 2 at a time, or FOIL 2 at a time, and it would probably take up between a half of a page and a full page of work for you just to figure out what that ended up to be once we got it all multiplied out. Pascal's triangle actually shortcuts you and gets you that answer a lot faster. Notice what the pattern is, because you're going to have to be able to reproduce it. You're not going to be given this on a formula sheet anywhere. You start with a triangle of ones. Each line starts and ends with a 1. The number that you see in the middle, or the numbers that you see in the middle, come from adding the 2 that are diagonally above it together. So 1 plus 1 is 2. That gives you this 2. This 3 comes from 1 plus 2. This 3 comes from 2 plus 1. This 6 comes from 3 plus 3. The 4 comes from 1 plus 3. The 10 comes from 4 plus 6, and so on. Okay, so there's tons of patterns, again, that you can find and work with in here, but you don't, it goes on forever. So I usually, produce myself a little sheet if I'm using it on a test that goes to like the 5 or 6 line. Now, the first line is the coefficient if you have something to the 0 power, because as you learned, anything to the 0 power is 1. And so we're probably not going to be working with that one. Also, the first line would be to the first power. So you would have 1x plus 1y. Not really interesting, probably not going to work with that one. This next line I use a lot. Let's say I had x plus y squared. That would mean I would have 1x squared, 2 xy's, and 1y squared. The next line would be x plus y cubed. And again, the coefficients in front of each term would be 1, 3, 3, and 1. Notice that the power that I'm writing here matches that first number that's not a 1 that you come to. So the next line would be x plus y to the 4th. There's a 4 right here. Your coefficients would be 1, 4, 6, 4, 1. And then the next line, 5th power, you match the 5, and these are your coefficients. So that's how you're going to choose what line to use, but again, you have to be able to reproduce this. Okay, so let's go to some examples of how to use this. The first one, I'm going to have v plus w to the 4th, and obviously instead of writing this out 4 times and foiling, I'm going to use Pascal's triangle. The first thing that you want to do is look up the line that has the 4th power, or the first number after the 1 is a 4, and write those coefficients, but put some space between them, because we're going to be putting things in there. So 1, 4, 6, 4, 1, all spread out. And then whatever is in the first place right here, like this, where this v is, you're going to start that on the left side, and you're going to take it to the power that the problem has. So this will be v to the 4th. And you're going to move 1 to each number, but you're going to go down in power. So this was v to the 4th. The next one will be v to the 3rd. The next one will be v squared. Then v, and you should run out, because v to the 0 power is 1, and we're not going to write that. Then your next move is to do the w, or where, whatever you have in that spot, to the power of the problem, but start on the right end and work to the left. So 1w to the 4th, and then w cubed, w squared, w, and then you should run out by that last one. Okay, something also to notice at this point is, before we simplify or anything, all of the coefficient pairings add up to 4. So here I have a 4, Here I have 3 and 1W. 3 and 1 is 4. 2 and 2 is 4. 1 and 3 is 4. And then the last one is 4. They all add up to the power of the problem. So if you've got something out of order, it's easy to notice. Now, the thing is about the signs. If there's a plus between them, like we have, then you put a plus between everything. If it is a minus, we will alternate, and I'll have that coming up in in the next problem. At this point, if you can simplify, you do, but ours, we don't have anything to multiply or simplify. This is the answer. This is what you would get after a page of work to multiply all of that out. For our second example, we are to the 5th power, so we're going to look up that one, that row that has the 1 and then the 5, and write those coefficients: 1, 5, 10, 10, 5, 1. Make sure you leave enough space. And I'm going to work the C from left to right, starting with the highest power. The problem there is a 5. So C to the 5th, 4th, 3rd, 2nd, and 1st. Then the 2, again, I'm going to start on the right and go to the left. So 2 to the 5th, 2 to the 4th, 2 to the 3rd, 2 squared, and then 2. I should run out by the end. This one has a minus, so my signs will alternate. Between the first and second one will always be a minus if this problem was a minus. So you'll start with the minus, then you'll go to plus, minus, making sure it's alternating all the way through. Now this one has one more step that we didn't have in the last one, and that is to simplify. And so I'm going to multiply these values of 2 with the coefficients to make the problem look the way that it would if I had multiplied it all the way out by hand. So 1c to the 5th, I would probably just write c to the 5th. Then I'm going to have 5 times the 2, so 10 c to the 4th. Then the next one, 2 squared is 4, times 10 is 40. So 40c cubed. Then 2 cubed is 8. 8 times 10 is 80. So 80c squared. And then 2 to the 4th is 16. Times 5 is also 80. Just c with that one. And then minus 2 to the 5th. 2 to the 5th is 32. So this is the simplified version. Okay. You can't look at this one and see that the power was 5 if you're adding those. You have to look at this line and say, okay, 4 and 1 was 5, 3 and 2 was 5, 2 and 3 was 5, if you're checking that. Okay, in number 3, I added a little bit more of a challenge because I put the 2 with the A, and so I'll show you how we deal with that. First of all, this is to the 3rd power. And so my coefficients are 1, 3, 3, 1. And this time, since there is a 2 and an A, when I write these and work from left to right, I'm going to put them in parentheses. So 2a to the 3rd, 2a squared, 2a, and then I run out. I'm also going to work backwards with the b from right to left as normal. So b to the 3rd, b squared, b. Since this problem had a plus, everything gets plus. And again, I can check my power here. I have power of 3, 2 and 1 is 3, 1 and 2 is 3, 3. That's before I simplify. Now I'm going to simplify. You have to cube the 2 and the a. So this is 1 times 2 cubed, which is 8, times a cubed. So 8a cubed. The next one, you're squaring the 2 and the a, so you get 4 and a squared. 3 times 4 is 12, so 12a squared b. On the next one, it was to the power of 1, so we can just multiply 6ab squared. And the last one, 1b cubed, we usually just write b cubed. So now example 4 would be an excellent one for you to try. If you want to pause and try that one on your own, do so now. Okay, you should have started with 1, 4, 6, 4, and 1. And then taken the x to the 4th and worked left to right. So x to the 4th, x to the 3rd, x squared, and x. Then taken the 3y and worked right to left. So 3y to the 4th, 3y to the 3rd, 3y squared, and 3y. Then your signs, because this was a minus, would have been minus, plus, minus, plus. At this point you can check your powers and then simplify. So I have x to the 4th minus 12x cubed y. Don't forget to square the 3 and the y here. And so that would be 6 times 9, so 54 x squared y squared. And then the next one you have 3 cubed, which is 27 times 4, so 108 x y cubed. And then your last one, 3 to the 4th, is 81, so 81 y to the 4th. And so that is the simplified version of number 4. Okay, example 5, I added this one in because I wanted to show you what to do if the variables already had powers. And again, if you just keep it in parentheses and know your power rules, you'll be okay. So our power of the problem is 4, so our coefficients are 1, 4, 6, 4, and 1. And then what you're going to do is put parentheses around these as you work down. So x squared to the 4th, x squared to the 3rd, x squared to the 2nd, and then x squared. And then the same thing with the y cubed as I work from right to left. So y cubed to the 4th, y cubed to the 3rd, y cubed squared, and y cubed. This one has a plus between it, so everything has a plus as the sign. And then you have to remember that with power to a power, you multiply the exponents. So 1x squared to the 4th, you're going to multiply and just get x to the 8th. On the next one, your x should be to the 6th when you multiply, and your y is still to the 3rd. On the 6th, you get x to the 4th and y to the 6th. The next one I have x squared, and then 3 times 3 is 9, so y to the 9th. And then on the last one, 3 times 4 is 12, so y to the 12th. So that's what you get when you simplify something that had powers to begin with, and that concludes this lesson.